where so we've already established where the equilibrium price and equilibrium quantity comes from, anyway, where demand and supply meet. If the price was too high, there would be a surplus, the price would fall, move along demand and supply until the market reaches an equilibrium. If the price was too low, there'll be a shortage, the price would go up, move along demand and supply until the market reaches an equilibrium. Now, we haven't talked about what will happen if some sort of event were to occur in the market. So, let's say, again, let's say this was the market for apples. And there was some sort of scientific discovery that apples are, some previously unknown knowledge that apples are healthy for you. So some event occurs. So let's say, for example, the quality of apples improves. There's an improvement in quality of the product. Now, the way you approach this kind of situation is, firstly, you ask yourself, what is affected first? So, steps to approach this situation. Firstly, start at equilibrium, E1, where D1 and S1 meet. So before you approach any kind of question on demand and supply, you start off with this default diagram. Demand and supply and the initial equilibrium. That's where you first start off. The second step is you look at the scenario and decide whether the scenario impacts demand or supply. And we're looking at the initial impact. So once you've started off at the initial equilibrium, you look at whatever is presented to you and you decide whether the initial impact is on demand or whether the initial impact is on supply. It's important to consider who the initial impact is on. So in this case, since it's about the quality of the product, the initial impact will be on demand. Yeah. The initial impact is going to be on demand. So now that demand will have to shift either to the left, closer to the origin, or to the right, further away from the origin. So since it's an improvement in quality, demand will shift further towards zero or further away from zero. Demand would shift further away from zero. Everyone okay with that? So there's an improvement in quality of the product, and demand would shift further away from zero. So this is your initial demand curve, and the demand curve would now shift further away from zero. We'll call that D2. So, step 1, you start at the initial equilibrium. Step 2, decide which curve is going to shift. Then the third step is shift the relevant curve. And once you've shifted the relevant curve, the fourth step is you look at the new equilibrium that you've just created. So the initial demand is no longer. You mark the new equilibrium. We'll call that E2. So the fourth step is mark the new equilibrium. E2. And then you look at what is the new equilibrium price and what is the new equilibrium quantity. You look at what is the new equilibrium price and what is the new equilibrium quantity. So what has happened to the price if you look at this example? If you compare E1 and E2, the price has gone upwards, up, and the quantity has gone up as well. So the last step is, once you've marked E2, you compare the two equilibrium points. Compare E1 versus E2. So that would be the step-by-step approach for attempting any sort of example or question on demand and supply. You start with the initial equilibrium. You look at what's given to you, decide which curve is going to shift. In this case, it's demand. You shift the appropriate curve. You mark the new equilibrium, and after doing that, you see what has happened to the equilibrium price and what has happened to the equilibrium quantity. Is that okay? The reason I'm asking you to go by this step-by-step approach, it may look very obvious to some of you. What happens in exams, multiple choice questions especially, students get tricked or confused. Some students approach it this way. The scenario was the quality of apples has gone up. So they start to think in their mind, if the quality of apples has gone up, that means the price of apples would increase. Therefore, suppliers would want to sell more, and they decide to shift the supply curve to the right. Now that sounds logical beyond the economics we've looked at, but that sounds sort of logical, doesn't it? Price of apples, quality of apples has gone up, so they infer in their head, therefore the price will go up, and if the price goes up, supply should shift to the right. The problem is, they haven't looked at the initial impact. The initial impact is not on the seller. If the quality of apples improves, the initial impact is on the demand, the buyer. Yeah? If you're a seller, you're not going to just sell more apples just because the quality of apples has gone up. You're going to sell more apples if the price of apples goes up, which it has here. So does the graph tell us how sellers will respond when the price of apples increases? Yes. If you look carefully at the supply curve, sellers have responded to the increase in price. As the price of apples goes up, what do sellers do? Do they produce more? Yes. So can you see how the sellers are not responding to the improvement in the quality, rather they are responding to the increase in the price. So the model already tells you how the other party reacts. You need to decide who the initial impact is on, and then the other party will react to that shock, that shift or that shock. So you decide which curve shifts, you shift the relevant curve, you look at the new equilibrium, you compare that to the old equilibrium, and the other party will react along their curve. So in this case, sellers will react along the supply curve. So they're not necessarily reacting to the improvement in quality. They'll react to the improvement in quality because there is a subsequent increase in the price. Is that okay? So again, this is a very common mistake. Students look at a situation where quality has improved. So if the question was the quality of apples has improved, they start to think in their head, quality has gone up, therefore suppliers would want to sell more, and then they shift the supply to the right and the price of apples falls, and they've got the total opposite answer. Because they've thought 2 steps ahead. Don't think 2 steps ahead. Think always what is the initial impact. So the way economics works is you're not supposed to come up with the final answer. You're supposed to come up with what is the initial shock, what is the initial impact. The model will give you the final answer. That's the idea of the model in the first place. Otherwise, we wouldn't need the graph to begin with. So the way you think in economics, any economic subject, you read whatever's presented to you, and then you need to decide which of the 2 curves is going to shift. You're not supposed to come up with the final prediction. The final prediction is from the model. Does that make sense, the way of thinking? So don't ever stress thinking the question is requiring what the final answer is. Rather, the question is wanting you to figure out what component of the model is affected, and then what is the prediction of that model. So the model tells you, okay, when demand is impacted, the price will increase and the quantity will increase. So you've got to train your mind, and no matter how many times I say this, you will get confused when you do different questions, because students by default try to figure out P and Q in their head. Don't figure out P and Q in your head. Figure out demand or supply in your head, and the model will work out P and Q for you. I'll give you another example. Let's say there's an improvement in the technology of production. So not the technology of the product, technology of production. So what if there's an improvement in the technology of production? So always, step 1, start off with this blank graph. Step 2, figure out who the... So don't think 2 steps ahead and think what will happen to the price. You're just thinking who will be initially impacted. Production. The initial impact will be on buyers or sellers? Sellers, because they're the ones producing. It's production. The production process is the other sellers. So the curve that's going to shift now is supply. Shift closer to 0 or shift further away from 0? There's an improvement in the technology of production, so firms will be able to produce more than before. Would you agree with that? So supply will shift to the right. So the initial impact is on supply. Supply will shift to the right. The fourth step I've given you, mark the new equilibrium. So look at what happens if supply were to shift to the right. And if supply were to shift to the right, what will happen to the equilibrium price? The equilibrium price would decrease and the equilibrium quantity would increase if supply were to shift to the right. Is that okay? Are buyers buying more? Yes. If you look at the movement from E1 to E2, yes, buyers are buying more. The quantity demanded has increased. But buyers are not buying more because the technology of production has improved. The reason buyers are buying more is because of the subsequent decrease in the price. Yeah. Until the price actually falls, the buyers are not actually going to buy more. So the initial impact is on sellers. Sellers are producing more than before, which consequently drags the price down, and then buyers react along the demand curve. Is that okay? So another example of how this could go wrong for a student is they read the scenario, the technology of production has improved, and they think therefore prices should fall. Therefore, if prices fall, demand will increase, demand will shift to the right, and then come up with the exact opposite answer. Because rather than looking at the initial impact, they've thought 2 steps ahead and looked at the secondary impact, and they've shifted demand to the right. So if you train your mind to always think initial impact, not just this topic, any topic in economics, whichever economic subject, you're always thinking in terms of, hello, is it just my amazing voice that's projecting and not the mic? You're always thinking in terms of who the initial impact is on. Yeah? All good? Happy? Okay. The last couple of pages there, we're saving it for this afternoon in the tutorials. So we'll look at the new topic, elasticity. If you haven't already, you can grab that handout from the front, please. So we've established the law of demand, which is as the price goes up, the quantity demanded would go down, and the law of supply, as the price goes up, the quantity supplied will go up. Where this idea of elasticity fits in is, elasticity is just a fancy word for sensitivity. It's a fancy word for responsiveness. So we want to add a bit more information to the law of demand. The law of demand is a negative relationship between P and Q. The law of supply is a positive relationship with P and Q. With elasticity, we want to add one more tier of information, which is how big or how small are these changes. Are they big changes in quantity or are they large changes in quantity? So we already know if the price goes up, the quantity demanded would go down. Elasticity is about, does the quantity demanded go down by a lot or does the quantity demanded go down by a little? So it's captured by this idea called elasticity. How sensitive is the quantity to a change in price? Or how responsive is the change in quantity to a change in price? So if I was to ask you, the price of petrol has risen by 10 cents and the quantity of cars pumping petrol has reduced by 1,000. Is that quite sensitive or not very sensitive? The price of petrol has gone up by 10 cents and the quantity demanded has gone down by 1,000 cars. Is that sensitive or is that not so sensitive? Or what in the world is he asking me? That question does not make any sense. It's hard to judge because what are we comparing 1,000 to? Is it North Ryde? Is it all of Sydney? Is it all of New South Wales? Is it all of Australia? We haven't said what we are comparing 1,000 to. So it depends where we started off to begin with. So when it comes to judging whether something is big or something is small, you can't just look at raw numbers because you need to look at what are you judging it against. So when we talk about elasticity, we need to look at what is the percentage change in quantity and what is the percentage change in price. Then we can make a judgment about whether something is sensitive or not. You can't just say 10 cents. I guess 10 cents you know, because petrol is around $1.40. So 10 cents consumers would consider that to be a significant change in price. But 1,000, if it's compared to just one street, that's quite a lot. If it's compared to all of Australia, that's quite a little. You need a reference point. So elasticity is a ratio of percentage changes. So i.e. elasticity is a ratio of percentage changes, which you have on the bottom of page 4. You need to look at elasticity in terms of percentage changes because 1,000 could be a lot. If there's only 2,000 cars on the street, 1,000 could be very little if you're comparing it to 20 million cars in Australia. So we need to look at it in terms of percentage changes. So, which one is sensitive and which ones are not sensitive? If the percentage change in quantity is larger than the percentage change in price, So for example, let's say Woolworths has a 5% of everything sale and their quantity changes by 20%. So Woolworths advertises, we're going to reduce all our prices by 5% and the quantity demanded changes by 20%. Is that sensitive or not so sensitive to the price? The price has changed by 5%. The quantity has changed by 20%. Sensitive or not so sensitive? It's quite sensitive to the price, isn't it? A 5% of everything sale has caused the quantity to rise by 20%. So this case, demand is quite sensitive to the price. The reverse. If the percentage change in quantity was smaller than the percentage change in price. Woolworths has a 5% of everything sale and the quantity goes up but by just 1%. You can see my mistake there. Woolworths has a 5% of everything sale and the quantity goes up but by only 1%. Is it quite sensitive to the price? No. So this is not very sensitive. Is that okay? So, when we look at elasticity, we're looking at how sensitive or not sensitive something is, or how responsive or how not responsive something is. Now, we don't use the word sensitive. We use the technical term. We use the term elastic if it is sensitive to the price. And instead of the term not very sensitive, we use the term inelastic if it is not very sensitive to the price. So if the percentage change in quantity is bigger, it's quite responsive. If the percentage change in quantity is smaller, it's not very responsive to the change in price. Now, what's the third possibility? The third possibility is they could be the same. If the percentage change in quantity equals the percentage change in price, so they have a 5% off everything sale, and the quantity also changes by 5%. Now, this is just a term. We use the term unit elastic. If the percentage changes are equal. Is that okay? So, bottom of page 4, in terms of summarizing this, how do you calculate elasticity? Elasticity symbol epsilon is simply percentage change in quantity divided by the percentage change in price. Now, at this point, we tend to lose 1/4 of the audience, if not more, because I've just given you an equation and now you're all stressing and now you all hate economics and you're like, I hate Prashan, I hate economics. Can you calculate percentage changes? If you can calculate a percentage change, then you can calculate elasticity. It's not really a new formula. I mean, if there was a product that was selling for $100 and now it's selling for 90, what is the percentage change in price? 10%, right? You all know that. If we sold 1,000 units before, and now we're selling 1,200 units, what is the percentage change in quantity? 1,000 became 1,200? 20%. Yeah, you all know how to do that. So if you can calculate percentage changes, you can calculate elasticity. Top of page 5. How do you calculate a percentage? How do you calculate a percentage change? You look at the change and you divide by the original number. And how do you calculate the percentage change in price? You look at the change divided by the original price. Now, just to make this a bit more real for you, so let's say $100 item, the price used to be $100. It has now been discounted to $90. We used to sell 1,000 units, and now we are selling 1,200 units. Can you calculate the percentage changes and calculate the elasticity, please? I'll give you 2 minutes. 120, 119, 118, 117, 116, 115, 114, 113, 112. So let's say your textbook used to cost $100. 1,000 textbooks were sold every semester. Now the textbook costs $90, and now 1,200 books are being sold every semester. What is the percentage change in price? What is the percentage change in quantity? Let's start with the percentage change in quantity. How do you calculate a percentage change? You look at what the change is to begin with, which is how much? 200. Then you divide by what? Do you divide by 1,000 or do you divide by 1,200? We used to sell 1,000, now we are selling 1,200, so we divide by 1,000, whatever we started off with. So divide by 1,000, which is 20%. What is the percentage change in price? The price changed by $10. The price used to be $100. The change in price is 10%. How much is elasticity? Elasticity is when you divide the percentage change in quantity by the percentage change in price. So how much is elasticity? 20 divided by 10, which is 2. The value for elasticity is 2. Not too hard? It's okay, right? What does that 2 mean? Back to this equation. Elasticity is percentage change in quantity over percentage change in price. Now, if something is elastic, which one is bigger? If something is elastic, what is greater? The percentage change in quantity or the percentage change in price? If something is elastic, the percentage change in quantity is larger than the percentage change in price. So that means the number on top is larger than the number on the bottom. Do you agree with that? If something is elastic, the numerator is greater than the denominator. Now, if the number on top is bigger than the number on the bottom, the answer has to be more than 1. From school, you can try on your calculator, pick any 2 numbers. If the number on top is larger than the number on the bottom, the answer will be more than 1. If the number on top is less than the bottom, i.e. if the numerator is less than the denominator, then the answer will be less than 1. Okay? So if you could add to this, please. If something is elastic, the value of elasticity will be more than 1. If something is inelastic, the value of elasticity will be less than 1. And if something is unit elastic, the answer will be equal to 1. So that's what the 2 means. What does the 2 mean here? Is the product elastic or inelastic? Is 2 more than 1 or less than 1? 2 is elastic because the number is more than 1. Yeah? So if you could add, therefore the product is elastic. It is sensitive to the price. We've only had a 10% change in price, but we've had a 20% change in quantity. The product is elastic. Is that okay? Now, just make a note, please. I haven't put any minus signs here. Technically, the change in price is negative, and the change in quantity is positive because the price has gone up. Sorry, the price has gone down and the quantity has gone up. Just make a note. It is convention to not include the minus sign for price elasticity. If you could add that, please. It is convention to not include the minus sign for price elasticity. It is convention to not include the minus sign for price elasticity. Can you see why? Because if the price goes down, the quantity will definitely go up. And if the price goes up, the quantity will definitely go down. So that minus sign is next to meaningless because it will always be negative. It's not giving you any more information. So the reason your textbook, most textbooks don't include the minus sign is because the answer will always be negative anyway. There's no extra information given if you put that minus sign because of the law of demand. If the price falls, the quantity will increase. If the price rises, the quantity will decrease. So a minus sign doesn't give you any more information. Is that okay? You like it? Okay, let me give you another example. Sorry, what am I doing? The price is 90. The price has gone up to $100. We used to sell 1,200 textbooks each semester. Now we are selling 1,000 textbooks each semester. Can you calculate the price elasticity, please? So first calculate the percentage change in price, then calculate the percentage change in quantity. And then divide across. How do you get the percentage change in quantity? You look at the change here. How much is that? 200 divided by what? We used to sell 1,200. Now we are selling 1,000. So 200 divided by 1,200. Because we used to sell 1,200. So the percentage change in quantity is 16.67%. Percentage change in price. The price has increased by $10. It used to be 90. The price has increased by 11.11%. So 16.67% divided by 11.11% gives you a value of 1.5 for elasticity. Is that okay? Is that elastic or inelastic? Elastic because the answer is more than 1. Now, does that answer surprise you? Because what's so unique about these numbers? What's so special about these numbers? It's gone again. What's so special about these numbers? Look at the previous example I gave you. The first example, the second example, what do you notice? $100 becomes $90, $90 becomes $100. 1,000 becomes 1,200, 1,200 becomes 1,000. I've just reversed the numbers. But do we get the same answer for elasticity? No. So if you could add a conclusion, you don't get the same answer for price elasticity for a price decrease and a price increase. You get different answers. You get a different answer for a price decrease, and you get one answer for a price decrease, and you get another answer for a price increase. You get different answers for price elasticity. Because if a $100 item becomes 90, what's the discount? 10%. If a $90 item becomes 100, what's the increase in price? 11.1%. Because it's 10 over 90, not 10 over 100 anymore. Yeah? If 4 becomes 5, what's the percentage increase? If 4 becomes 5, that's 1 over 4, which is 25%. But if 5 becomes 4, what's the percentage decrease? 5 becomes 4, so you've changed by 1. 1 divided by 5, which is 20%. So you don't get the same answer for a price decrease compared to a price increase, because the percentage changes are not the same. So if we map that out on a graph, we had $90 and we had $100. And we had 1,000 textbooks and 1,200 textbooks. When the price went down, we got an answer for elasticity of 2.0. But when the price went up, we got an answer of elasticity of 1.5. We get different answers for a price increase and a price decrease, because the percentage changes are not the same. When 100 becomes 90, that's a 10% discount. But when 90 becomes 100, that's an 11.11% increase in the price. So the answer you will get is different, which is amazing, isn't it? It's going to keep you up all weekend thinking about that idea. And because it's so exciting, I'll just give you a 7-minute break. So do we get the same answer for price elasticity for a price decrease compared to a price increase? No. We don't get the same answer because our reference point changes. If the price decreases, that's our reference point. So the price has changed by $10, so that's a 10% change in price compared to 100. But if that's our reference point and we start at 90, that's a $10 change compared to $90, which is 11.11%. So we do not get the same answer for a price increase compared to a price decrease. So, to solve this quote-unquote problem, to solve this quote-unquote issue of getting a different answer for a price increase compared to a price decrease, there is a solution to give us the same answer. The solution is what I just told you on page 6. The solution is this. Elasticity is percentage change in quantity divided by percentage change in price. Elasticity is percentage change in quantity divided by percentage change in price. And let's say the price now, $10 divided by 100 is 10%. $10 divided by 90 is 11.11%. We can solve this problem by neither dividing by 100 nor dividing by 90. Instead of dividing by 100 or dividing by 90, we could divide by Instead of dividing by 100 sometimes and dividing by 90 sometimes, what number could we divide by to give us the same answer all the time? 95, the average of the two. So instead of dividing by either, we could divide by the average, 95. This way, even if the price went up, we'll be dividing by 95. And if the price went down, we'll still be dividing by 95. Likewise for the quantity. Instead of dividing by 1,000 when the quantity goes up, or dividing by 1,200 when the quantity goes down, we could just simply divide by 1,100, which is the average. Can you try that, please? Can you see what the answer for elasticity would be if you calculate it this way? So instead of using either point as the reference, we use the average as the reference point. So 200 divided by 1,100 gives you 18.2%. And 100 divided by 95 sorry, 10 divided by 95 gives you 10.5%. $18.2 divided by 10.5 gives you 1.73 for elasticity. Is that okay? So the motivation behind this, top of page 6, is, if you could add to the top of page 6, this gives us a consistent answer whether the price went up or the price went down. This gives us a consistent answer whether the price went up or the price went down. Because what we are essentially doing is we're not comparing, we're not referring to 100 or referring to 90, we're referring to the average, 95. So if you always refer to the average, it wouldn't make a difference whether the price went up or the price went down. So just a term, this is known as the midpoint formula, that's just the name. All it does is, instead of dividing by the original quantity or the original price, we divide by the average quantity and the average price. This way you get one answer, whether you go up or down, you'll just get the one answer for price elasticity, which is 1.73. Is that okay? In terms of exam questions, it will be clear to you. It will say, use the midpoint formula or not, so don't need to stress. The principle doesn't change. You are still calculating percentage changes. The only difference is, rather than dividing by the original numbers, you are dividing by the average numbers. Is that okay? Okay? So, if you're thinking, oh my gosh, there's like a million formulas you've shown me already, not really. I've only shown you one, which is percentage change in quantity divided by percentage change in price. And it's not really a formula because all of you know how to calculate percentage changes already. So it's the ratio of two percentage changes. Yeah? If something is sensitive, the numerator, the top number, is larger than the denominator. So the answer will be greater than 1. If it's not very sensitive, the top number will be quite small. The numerator will be small compared to the denominator. The answer will be less than 1. If the two are equal, the answer will be 1. Bottom of page 12, please. So the numerical examples in your slides are different numbers, so you can go through them in your own time. Exactly the same, but just different numbers. Bottom of page 12 is a very special demand curve. What's so special about that demand curve? Bottom of page 12. It's vertical. Is this product sensitive to the price? No. No matter what happens to the price, whether the price were to go up or go down, the quantity is exactly the same. It is perfectly insensitive to the price. No matter what the price is, the quantity remains unchanged. It's perfectly inelastic. we say that elasticity equals 0. It is not sensitive to the price at all. No matter what the price is, the quantity demanded is the same. Usually students say water, but then I ask them, if Sydney Water charged you $30 a litre for water, would you reduce your water consumption? You have no idea because you don't pay your water bills, your parents pay your water bills, and you don't even know if 30 is a lot or a little. If they charge you a very high price for water, you'd reduce the amount of waste you have, isn't it? You'd take shorter showers, you'd wash your car less often, you wash your garden less often, you might not take a shower at all, just to save some water. So you can't argue that water is perfectly inelastic. You would reduce your consumption somewhat. Something like this could be maybe a life-saving medication, if you had the income. Regardless of what the price is, the quantity of that medication that you buy would be the same. Of course, it may differ from person to person, but in general, if it was a life-saving medication, regardless of the price, the quantity that you demand would be constant. Top of page 14, another special case. Is this demand curve sensitive to the price? If the price were to increase, the quantity demanded would be 0. This consumer only buys the product if the price is the original price, P1. Any other price, the quantity demanded is 0. So the demand is very sensitive to the price. We say that it is perfectly elastic. It's extremely sensitive to the price. Now, we'll see examples of this much later when we discuss a topic called perfect competition. So, coming up later. I know you can't wait. Raise your hand if you can't wait. But it's coming later, don't worry, yeah? If you really can't wait, just maybe look at the textbook, have a sneak peek. Yeah? But it's coming up later in a topic called perfect competition. Okay? It's very sensitive to the price. So we say that elasticity is, what's that symbol? Infinity. It's extremely sensitive to the price. Elasticity in numerical terms is infinity. Now the special demand curve on top of page 13 we'll come to later. I'd like you to look at page 15 and 16, the pair, please. And I ask you to make a few of these. Everyone okay? Say yes. By the way, this is the only topic with maths like this. This is not indicative of the rest of the course. And traditionally, this is the topic that everyone hates. Do you hate this topic? Raise your hand. 2 people. So traditionally, elasticity is the least liked topic. If we ever give it in an exam and it's choose 1 out of 3, this one is the one that people tend to avoid. I'm not sure why, but anyway. So there is a bit of maths in this, but other than that, the rest of the course is like what we did on Tuesday. Not so much maths at all. Okay, this is a demand curve. It's a linear demand curve because the change in price is always 5 and the change in quantity is always 10. What is the slope of this graph, please? How do you calculate slope? Slope is rise over run, or the vertical change divided by the horizontal change. Now, in this graph, the vertical change of any triangle is 5. And the horizontal change is 10. Agree? So the slope is 5 over 10, which is 0.5. Not too hard? Pretty okay? That's the third mishap with the tables. We need to screw them, isn't it? Or it's just so exciting that you just drop your books all the time. Just can't control it. So the slope is 0.5. So how do you calculate the slope? Vertical change over horizontal change. So in general, the vertical is price, and the horizontal is quantity. Yeah? Slope is delta P, change in P, over change in Q. Is that okay? Not too hard? Change in the vertical, which is price, divided by change in horizontal, which is Q. That's okay, right? Okay. Now put that aside. Now, I'm going to show you a mathematical proof. You don't need to know this. Don't stress. I'm just showing this for completeness sake. And because it's fun. How do you calculate elasticity? Percentage change in quantity divided by percentage change in price. Yes? Elasticity is percentage change in quantity over percentage change in price. How do you calculate a percentage change? You look at the change, divide by the original. How do you calculate a percentage change in price? The change divided by the original. Agree with that? Now, that is exactly the same if I write it this way. Delta Q, QO divided by delta P, PO. Yes? That's just a division sign. Yeah, that's a division as well. Now, from school, dividing by a fraction is the same as multiplying by the inverse or the reciprocal. Again, I'm just showing you this for fun. You don't need to prove this. I'm just showing it to you for fun. Yeah? Now, notice my voice gets louder and louder because it's getting more and more exciting. I just swapped the position. Is that allowed? I've just changed the position of those two variables. Yeah? So all of that is exactly the same. Don't worry, I'm just showing you this for fun. Now, what did I say the slope was? What is the equation of the slope? What did we say? Delta P over delta Q. Change in vertical divided by change in horizontal. So slope is change in price over change in quantity. Can you see the relationship between elasticity and slope? What is the relationship between elasticity and the slope? Slope is change in P over change in Q, but elasticity is change in Q over change in P times P over Q. You don't need to prove this, so I'm just giving you the final result that elasticity is 1 divided by the slope times P over Q. This formula you do have to know, yes. It's just another way of writing the elasticity formula. You don't have to prove it. I just proved it for you to show you that it is the same, but do write that somewhere, maybe highlight it, maybe underline it twice, maybe underline it 3 times, maybe 4 times. Just keep underlining it. I don't like the number 6 actually, 7. Yeah. You need to know this. Do you need to prove it? Do you need to prove it? No. So how many formulas have I taught you today? Really only 2. 1, 2. But actually it's really only 1 because I showed you that they are the same. But if you like, I'll take your side. We'll call it 2. But really, they are the same. I mean, even the colors are the same. Purple. Is that okay? Okay, now look at that formula and look at the graph we drew. Keep that on the side. Keep that on the side. And let's apply that to this graph. So we're on page 15 and 16 in your slides. The numbers are the same, but you're not going to learn anything unless you apply it to yourself. Okay. Let's call this point B. How much is the elasticity? Elasticity equals 1 divided by the slope. How much was the slope? 0.5. What is the price at B? 20. What is the quantity at B? 10. 2 divided by 5 equals 4. Can you do the same for these points, please? Can you do the same for B, C, M, D, and E, please? So apply the same formula to all of these points, please. You can discuss with your friend sitting next to you. Of course, all of you decided to strategically sit within a bubble of 8 seats, so there is no one next to you. Only 2 of you have friends. 4 of you. Ooh. Is that better? In terms of that, but you probably can't see me. Do you notice there's something at the bottom? I just realized. What's that? I think it's the chain. You know that they chained this so that nobody would steal it? You should come and see the chain later. Oh dear. Okay, I'll just not touch it. Let's do C. Elasticity is 1 divided by the slope. How much is the slope? 0.5. What is the price at C? 15. What is the quantity? 20. What's the answer for elasticity? 1.5. Let's do M last. Elasticity at D, 1 divided by 0.5. What's the price at D? 10. What's the quantity? 30. 10 divided by 15, 0.67. What is the elasticity at E? 1 over 0.5 times 5 divided by 40, which is 0.25. What do you notice as you go from left to right? As you go from left to right, what happens to elasticity? Sorry? Yeah. As you go from left to right, elasticity is going down. Interesting, isn't it? As you go from left to right, see that shadow is a problem. As you go from left to right, elasticity is going down. What is the elasticity at M? 1 divided by the slope, 0.5. What's the price? 12.5. What's the quantity? 25. Elasticity equals 1. Why did I call it M? Because it is it's not a special name, I'm just called it M for fun, but it happens to be the midpoint of that graph. Now, isn't this interesting? The elasticity at the middle equals Do you see how I took that away? I'll draw it again. See, you can't do that. That's why I told you to draw it 3 times. For I only drew it once, but I have these wonderful things called overhead projector thingies. And then I've got the graph again. So in the middle, the elasticity equals, in the middle, the elasticity equals 1. Look at all the numbers at the top. All the answers are bigger than, all the answers are bigger than 1. And if you look at the bottom, all the answers are less than 1. And that's not just for this example. If you could add these results that you have on page 15 and 16 or here, these results are true for any linear demand curve. These results are true for any linear demand curve. If you don't believe me, when you go home tonight, make up your own linear demand curve and go for it. And then maybe you can bring your demand curve to class next time, and then we could share them. And then we go, wow, that's amazing. It's true for any linear demand curve. Not just Prashan's one, my one too. Make it personal. It's true for any linear demand curve. The top half is always elastic. The bottom half is always inelastic. And the middle is always unit elastic. It is true for any linear demand curve. The top is more sensitive than the bottom. Now, what's the intuition? There is an intuition here why the top half is more sensitive than the bottom half. The intuition is this. Let's say you are somewhere in the top half. You're only buying 10 units. If you change your quantity by 10, either by 10 more or 10 less, what's the percentage change? If you're buying 10 and you change the quantity by 10, what's the percentage change? 100%. If you're buying 10 and you suddenly buy 0, that's 100%. Or if you're buying 10 and you buy 20, that's again 100%. So 10 is a big percentage compared to 10. But if you're on this side, buying 40 or even buying 50, and you change your quantity by 10, 10 compared to 40 is only 25%. Or 10 compared to 50 is only 20%. See, if you're buying a lot and you change your quantity, it's a very small percentage. But if you're buying a little and you change your quantity, then that's a large percentage. That's the intuitive reason why the top is more sensitive than the bottom half. It's because for the top half, you're only buying a small quantity to begin with. So if you change your quantity now, that's a large proportion of the original quantity. But on this end, you're buying quite a lot. So if you change quantity by 1 or 2 or even 10, it's a very small percentage change. Does that make sense? So even though the change in quantity is always 10, for small quantities, that's a very large proportion. For large quantities, that's a very small proportion. So the top is way more sensitive than the bottom half of the demand curve. If you could add an intuitive reason in your own words, please, why the top is more sensitive than the bottom, otherwise you'll get lost in the numbers. There is some intuition. Every time you see a graph, look at it from a technical point of view, but obviously always look at it from an intuitive point of view as well. Why the top is more sensitive? Because you're only buying a few to begin with, so any change in quantity is a huge proportion. At the bottom, you're buying a lot already, so any change in quantity is a small proportion. So the bottom is less sensitive and the top is more sensitive. Because that's what elastic means. Yeah? Elastic means sensitive, responsive. Inelastic means not very sensitive, not very responsive. Why does a firm care about elasticity? Before we look at that, let me give you one definition. Total revenue, the price times the quantity. Total revenue, TR for short, is the price of the product multiplied by how many units have been sold. You can call it total revenue. You can also call it total expenditure. Because the revenue is from the firm's point of view and expenditure is from the consumer's point of view. So you can call it total revenue or you can call it total expenditure. I'll give you 2 minutes. Can you apply that formula to all of those points, please? Can you calculate the total revenue? Same letters as before. What is the total revenue at each of these points? So, for example, what is the total revenue at B? 20 times 10 is 200. $25 times 0, 0. 15 times 20, 300. 12.5 times 25, 302.5. 10 times 30, 300. 5 times 40, 200. 0 times 50, 0. What do you notice? As you work your way towards the middle, total revenue goes. As you work your way to towards the middle, total revenue goes up. But as you work your way away from the midpoint, total revenue now starts to go down. And again, if you could add, that is true for any linear demand curve, not just our example. Again, if you don't believe me, go home, make up your own example, multiply through. You will notice that total revenue always reaches a maximum, top of page 19 and 20. The highest total revenue is always where? At the midpoint. The highest total revenue is always at the midpoint. The maximum total revenue is always in the middle. Isn't that amazing? Yes, it is. Wow. So, there's a few special things about the middle. That's where we have the biggest total revenue. That's where we have elasticity equaling 1. Yeah? In the middle, elasticity equals 1, and in the middle, revenue is maximized. So I told you we're looking at why do we care about elasticity. Very last thing for today, we're looking at page 19 and 20. If you could draw two axes directly like this, please. One on top of the other. This is what you have on page 19 and 20. So what does total revenue look like? It reaches its maximum in the... just follow me for a second. We are drawing a graph for total revenue. So it increases until it reaches the middle of the demand curve. And then it begins to decrease. Isn't my total revenue curve amazing? Look how symmetrical it is. You think that's not a big thing? Now you try. You try draw a symmetrical total revenue curve. And if yours is better than mine, please raise your hand. No takers. Do you want to see something amazing? You have to promise to say wow at the end. I'll prompt you the first few times, but later on in the semester, the wows will come naturally to you. Okay, am I on the elastic side or the inelastic side? I'm on the elastic side. Look what happens if I increase the price. If I increase the price on the elastic side, what happens to the quantity? Now, according to the law of demand, if you increase the price, the quantity will go down. Yeah? look what happens to the total revenue. The total revenue goes down. Do you agree with that? On the left-hand side, I've increased the price and total revenue has gone down. You're wondering, why do you tell me to say wow? The wow moment hasn't come yet. That's why. The wow moment is coming. Stop writing for a second. Do you want to see the wow moment? Look what happens on this side. What side is this? This side is elastic or inelastic? This side is inelastic. Some of you can already see it coming. Now look, if I increase the price on the inelastic side, what happens to total revenue now? Does it go down? Now it actually goes. This is where you say 1, 2, 3. Oh my gosh. It is exciting because what I showed you before, on the elastic side, if you raise the price, total revenue will go down. On the inelastic side, if you raise the price, total revenue will go up. That's amazing. Yeah. That's why elasticity is useful for a firm to know, because it allows you to predict the impact on your total revenue. If you could add that as a conclusion, please. Knowledge of elasticity allows a firm to predict the overall impact on the total revenue. Knowledge of elasticity allows a firm to predict the impact on their total revenue. If you raise the price on the elastic side, your revenue will fall. And if you raise the price on the inelastic side, your revenue will actually rise. So you get a different answer when demand is elastic, and a different answer for demand is inelastic. Is that okay?